The Martin B-26 Marauder was a medium bomber that earned a grim reputation early in its career, earning the grim nickname One a Day in Tampa Bay due to frequent training crashes near MacDill Field in Florida. At one point in 1941 to 1942, during the initial rush to train new pilots, there were 15 crashes in a single 30-day period. The plane's high-speed, high-wing loading design made it unforgiving during takeoff and landing, posing a lethal risk to inexperienced pilots and threatening to get the entire B-26 program scrapped. But with pilots' lives and the war effort at stake, engineers were forced into a high-stakes race to save the aircraft. They made three crucial engineering changes that transformed the B-26 from a dangerous liability into one of the most successful and survivable bombers of World War II. The original B-26 Marauder's short wingspan was a major contributor to its high landing and takeoff speeds. This was a direct result of Martin's design philosophy to minimize drag and increase top speed. However, this high wing loading, the aircraft's weight divided by the wing area, made the plane unstable at low speeds, which is critical during the most dangerous phases of flight. To address this, engineers implemented a significant modification on the B-26B model. They extended the wingspan by 6 feet, from 65 feet to 71 feet. This simple but effective change increased the wing area and, consequently, reduced the wing loading. The result was a lower stall speed, allowing for safer takeoffs and landings. The improved control and stability at low speeds dramatically reduced the number of accidents. The early B-26 models were powered by Pratt & Whitney R280-43 double wasp engines, which, while powerful, contributed to the plane's high stall speed and challenging handling characteristics. For example, during takeoff, the powerful engines required significant pilot input to prevent the plane from veering off the runway. The original propellers were also a point of concern as they were not always optimized for the plane's high-speed design, and propeller pitch control issues sometimes led to overspeeding or insufficient thrust. Engineers addressed this by upgrading to the more reliable and powerful R280-41 and 43 variants on later models. These engines featured improved propeller governors and more consistent power delivery. The change didn't just provide a slight boost in performance, it also improved reliability, which was crucial for a bomber operating over enemy territory. The enhanced engines, combined with the new propellers, made the plane's handling more predictable and less strenuous for pilots. Perhaps the most subtle yet critical change was the modification of the wing's angle of incidence. The angle of incidence is the angle at which the wing is permanently mounted to the fuselage relative to the longitudinal axis. The original B-26 had a relatively low angle of incidence, which was ideal for high-speed flight, but made it difficult to generate enough lift at low speeds, which required pilots to maintain a steep nose-up attitude during landing, making it hard to see the runway and adding to the already difficult landing procedure. In later models, the angle was increased by 3.5 degrees. This seemingly small adjustment had a massive impact. It allowed the wings to generate more lift at lower speeds without a severe nose-up attitude, which provided a more stable and predictable glide path. Pilots could land the plane more safely and with better visibility. The combination of the increased wingspan, improved engines, and a corrected angle of incidence transformed the B-26 Marauder. These three engineering changes didn't just make the plane safer, they turned it into a remarkably effective combat aircraft. The low wing loading and improved control made it more maneuverable at low altitudes, while its speed and powerful defensive armament made it difficult for enemy fighters to engage. The most telling result? The B-26 went on to have the lowest loss rate of any American bomber in the European theater, with a loss rate of less than 1%. Its transformation from the Widowmaker to one of the most respected and survivable bombers of the war is a testament to the power of targeted engineering improvements.